Okay.
You got some echo there, Ciara. You might want to.
Yeah. Is that better now?
Yeah, it's better.
Cool. Okay. Is everybody ready to kick off? Take that as a yes. So this is our Twitter handle. Christoph will be tweeting throughout the meetup if anyone wants to tweet him any questions or anything, or you can email us. We probably won't check that until after though. But if you want to do meetups for future ones, if you want to present or contribute in any way or help organise it, then just drop us an email. And yeah, we started doing this last year, around this time last year. The objective to learn and share and kind of meet each other and just kind of help each other learn C++ and Rust and see what the languages can do for each other and how we can learn about them and advance our ability. Two of us, so me and Chris, work for Esri and they sponsor the Meetup page. And we have a code of conduct. We follow the Rust code of conduct, which in turn follows the Citizens Code of Conduct, but the general gist of it is, you know, be wonderful to each other, be nicer than you have to be. And at physical meetups, we follow the Pac-Man rule, which means if you're having a conversation, try and leave a space. So if there's a newcomer and they don't know anyone, then they can kind of join in, fill the space, and then you open up a new one. It still applies virtually, kind of, but it's hard to implement. But if anyone is new or anyone wants to chip into any discussions, just know that that space is mentally there. It has been left open, even if you can't see it. We're going to start off with Chris's Game Jam Showdown Part 1. Yeah, good luck, Chris. This is a tough challenge you've set yourself. It's going to be some live coding going on with scoring, followed by Richard giving us highlights from the Microsoft CPP conference, and Hugh talking to us about Rust in real life, so what it's actually used for in real projects. And then we have a lightning talk. So David's going to be doing a lightning talk later. If anyone else has anything they can do in a lightning talk, then yeah, let us know and we can pop you on at the end. And without further ado, I shall pass you over to Chris.
All right, thanks, Ciara. Let me share my screen then. Okay, will you be seeing my screen? Can you see my screen? Yeah.
Yeah.
Cool. All right. So, just a bit of background on myself, I suppose. So, I've got a history from the games industry, so that's kind of where I kind of cut my teeth and kind of grew up. I've experienced in multiple different languages over multiple different disciplines. And now, as Ciara says, I kind of work for Esri and I program professionally C++ by day, and therefore I program unprofessional Rust by night, I would say. These are my handles if you're interested. Just one little caveat before we start. Originally, this was going to be part 1 and part 2 tonight, but there was talk about that could be too long. So I'm going to do a part 2 in our next meetup. So this is going to be part 1 tonight. So I have an ongoing series of Rust versus C++. I'm passionate about both languages quite a lot, but in the way of Highlander, there can only be one, particularly in my eyes. So in order to find out which one is best, we have to compare them arbitrarily in top trumps kind of style, very scientifically, to find out which one is the best. Now, previously, I had a Rust versus C++ showdown regarding compilation output, and as we saw by the results are actually quite comparable. So the compiled code of Rust and C++ is almost identical, slight variations, particularly with MSVC. So this kind of talk is, which tool is best for rapid prototyping with, and the best way that we're going to tackle this is by creating a game in 30 minutes from scratch in both languages, and that way we can conveniently test which is probably the best for rapid prototyping. Maybe we'll see. I hope this is at least fun. I don't know what it's going to be like just watching me code for 30 minutes, fielding questions or whatever. So we'll see if this works. So there are some pretty important rules before we're going to get underway. So both Rust and C++ are kind of working under the same rule sets to make it fair. So what we're going to do is we're going to build Pong with defined features, which we're going to get into in a minute. There's 30-minute maximum time limit for each game, and we're making it. The libraries that we're using can already be installed, so I'm not fishing around for them. We have to use the same environment and the editor, so I'm currently using Linux, and the editor will be Visual Studio Code. So we must start without a project to simulate when you're working on a game jam. You don't know what you're working on until you get there on the day. I'm only allowed to use official documentation for cutting and pasting. So if it's on the documentation, I can cut and paste it, because I don't think anybody writes code from scratch. Everybody cuts and pastes, right? Yeah. A dry run is allowed. So I have already done a dry run with the Rust project a couple of days ago, just to make sure that I'm not completely clueless, because you don't want to see me kind of fumble around for 30 minutes trying to remember how to do a cast to a U32. Also, I think it's unfair if I was completely blind, because then both projects won't be on the same kind of level of my understanding of how to put them together, and it might not be a fair test, even though this probably isn't a fair test anyway, but we'll gloss over that. The end results are all that matters, so this is going to be horrendously hacked together. The only thing I care about is that end result. So from start to finish, it's going to be copy and pasting. I'm going to be making lots of mistakes, and that is where you guys are going to come in. So if you see me make a mistake, shout it out. If you see me do a copy paste error, shout it out. If you think of a better way of doing it, a quicker way of doing it, shout out and let me know. And that way, together, we can hopefully make this interesting, and just not watching me fumble for 30 minutes. So, okay, we need to define our feature goals. So what are we actually trying to achieve in this project? So within the 30 minutes, what we have to do is you have to create a game. We have to create Pong. It has to have graphics. It has to have player paddle control. It has to have AI with paddle control. It has to have ball physics. So that's bouncing off the paddles on the walls. Random direction at the start, and also to display the score. So we're trying to achieve those 5 features by the end of those 30 minutes. And hopefully it can show you how easy it is to make a game in both these languages. So we're using some scoring metrics here. Ciara kind of helped me kind of put this together. So the score, this arbitrary score that we're going to get at the end of these two runs is here. So it's the number of completed features divided by the elapsed minutes, minus by the 2 times of the compiled build errors, and the number of warnings at finish. So every time I build the project and there's a build error, can somebody make a note of it? Maybe Ciara, if you want to write down kind of like I've made a compilation build error, and then what we'll do is we'll add that into the formula at the end.
Just for clarification, Chris, are there supposed to be brackets around the 2E plus W, or are you actually giving yourself a bonus for getting warnings?
This probably has to have a brackets around that. You can blame Ciara for that one.
This was not my suggested formula. I resent that.
And we're not counting the number of lines on the error output, do we?
No, we're not counting that. No, I think in Visual Studio it pops up with how many errors there are, and what we're doing is, well, and every time I build in the project and it fails, you mark it. But at the end, we'll count the number of warnings that I've got, and that also kind of negates from the score. Does everybody agree with that? I mean, like, I'm like, this is pretty, ridiculous, but
the value that comes out is arbitrary. That's the other thing to remember. It isn't actually going to be used for anything.
I believe it's fact, Ciara. Now, I think when you put it in a mathematical formula, it becomes true, doesn't it?
It might be also minus score, right? Negative.
Almost certainly going to be negative. There's a maximum of 5 features.
It depends what you're counting the time in. Oh, it does say minutes.
Yeah.
Okay, all right, so we're going to start. It's 12 minutes past 19, 12 minutes past 7. So 30 minutes from now, we should be called it. So Ciara, if you want to tell me at 15 minutes when I'm halfway through. That'd be nice. And
Great.
you have to tell me again when we're 30 minutes through. If there's any questions in the chat, let me know. Other than that, if you just want to get on the microphone and just shout abuse at me or just tell me I'm going wrong, I will greatly appreciate that, because I need that support. So I'm going to wait until it turns to 13 and then I'm going to start. We could be here all day actually, so I'm just gonna start and we can just call it 13. All right, okay. Here we go. Okay, so I have nothing, so I'm gonna have to create my project. I'm gonna call it Pong. Okay, and then I'm gonna get into that and bring it up. Okay, so we have our project in here. So if I can just quickly build it. So actually, that's the first thing I'm going to do. Is probably a bit time consuming, but I'm going to have to create my tasks for Visual Studio Code, if I can remember how to do it. Presentation, reveal, never, focus, clear, true. I think, yeah. It's a group way of doing it to make it as default, but I can't remember how to do it. So if anyone remembers how to do a Visual Studio Code task to set this up as, put the group as a default build, let me know. Okay, so this is our main. Okay, that's great. So let's start getting ahead. I'm going to use Quicksilver because I've used Quicksilver before. So let's kind of bring that up very quickly. Great. And then we're going to search for Quicksilver. And we're going to use this one here. So recently they just moved to Alpha 4, which I looked at, and it's completely different to 3. So we're just going to be using this one. So I'm going to have to bring that into my TOML and then put that dependency in. Okay, that's great. That's in. So like I said, I can copy and paste from a few documentation. So I'm just going to copy and paste this. And hopefully that could just run out the box. Okay, and then we build that. How's that frame rate? Is everybody following? Do I need to slow down a little bit? I'm not sure how the capturing is going.
That's keeping up so far.
Yeah, it's very good.
Cool. So it's building. Let's see what's going on here. So we're going to have to wait for all of this. So this is one of the drawbacks with Rust, is that there's a lot of compilation, and when you've got a lot of dependencies, it's got to go away and it's got to build them all and pull them all down. I'm just wondering why we're not seeing much going on. Okay, well, it's doing a lot of checking at the moment. So already we're being slowed down here by Cargo. I suppose what I could do is I could probably make these changes whilst this is happening. Okay, cool. So I'm going to change the window title, Pong. I'm going to change it to a resolution which is at least decent. So we do it 720p, which is 720 and 1280. Rename this Pong game. Right? That makes sense, yeah? Cargo is still building, great. So we've got some important stuff down here. So we've got drawing a triangle, which we don't want. What's this? This is drawing a line, which we don't want. This is a circle, which we do need for the ball. We're going to make it white. If you want to shout out a color for the ball color, let me know now. You can always change it later, I suppose. Okay, so we've got rectangles here for that's what we need for the paddle. So I'm going to go away, and whilst this is building, I'm going to create the bounds for the paddle width. Oh, I made a mistake already, I think. Which is going to be U32, and that's going to be, I don't know, paddle width, guys, 8. Okay, let's go for 8. If you want to shout out other dimensions, let me know. So height, we're going to go for, all right, we'll go for 32 because that's nice. We're also going to have the screen width as well. It's going to be 32 maybe, and that's going to be 1280. And I'm going to copy and paste this one, and I'm going to do it as, that's not how you spell height, 720. Okay, cool. So I should probably do this one down here. It doesn't really matter because we're kind of hacking it, but we're building, so I've done that wrong. Ah! Come on now. Come on now.
Are you using your tiny laptop for this, Chris?
No,
Oh, okay,
but
I was looking at the build speed and I was like, something.
no.
Still building.
Okay, cool. Right, that has built, but has it run? Oh no. We've got this all set up all wrong. Okay, I know what I've done wrong. Okay, so I need to get back into my tasks. I need to change this type to shell, of course, and the command is, oh, good grief. Tell you what, I'm coding these, I'm typing these, something to be desired. Okay, cargo run. Okay, and if you just do that. That is, okay, something's going wrong here. No, I'm just gonna do it the old-fashioned way. Okay. Cool. All right. Cool. We got some graphics on the screen. How long did that take? Too long, probably. Okay. So let's continue. So we need to change the color of the background to black because we cannot see the ball. That's not how you spell black. And we want to get these paddles kind of sorted out. So here is the X and Y position of the paddle, and this is the X and Y position of the ball. So we also need to add the positions in here. So we need position. I'm just going to do that as pos player 1 as a float 32, and then a pos p2 as a float 32 as well. And I've already, tell you what, if I type a little bit slower, maybe I would make less mistakes and I'd be faster in the long run. So now I need to assign this here, I think, if I remember correctly. So pos player 1 there, we're going to have to give it a vector, which is great. And we want to create a new vector. So this is player 1 position. Probably 30 pixels from the left. I should probably create a paddle padding here as well. That's going to be an F32, and there's going to be 30 units. So that's going to be paddle width. No, that's incorrect. That's what do I want? I want paddle padding. Paddle padding there, and we want it as screen height divided by 2. And we want to put it in the middle, so then we want to add the paddle height divided by 2 as well. So that should put us in the center. If you see anything wrong with my maths, please let me know, because I can't remember any of this stuff. Oh no, it's not liking this.
Pos P1 type is F32.
Not a vector.
Ah, thank you so much. Perfect. Okay, I'm gonna build that in a minute because I want to get marked down for this. Okay, so this is the paddle width, this is the paddle height, this is the self dot position 1, and that takes a vector, so that should be cool. And then we just bring this over here, paddle 2, but we want to change the position here of the screen. So we want the screen width minus paddle padding. Okay, it's not liking that. Hopefully that's just Visual Studio Code being silly. So, oh, okay, all right. So mark me down there for a build error. Oh, spelling mistake.
That's a minus, right? But as well, it gave you an information what might be wrong.
Yeah, I know, but the accuracy of this is quite important, I suppose. I think there's going to be another error here as well. So you can mark No, because did I build it? I didn't build it, so you can't mark me down for that. Screen width, paddle padding is float 32, so that means we're going to have to put it as a U32. And now I'm going to try running that again. Okay, so you're going to have to mark me down for that as well. So that's 2. And that's 3 as I try to brute force this because I didn't save it. That's why. Okay, so that should be good. What are we doing for time, Ciara? How much time do I have left here?
So I set a 15-minute timer. There's 5 minutes left on that.
So I've got 20 minutes.
Yeah.
Okay, cool. All right. So I got paddle. Probably wasn't in the correct location, but we're getting there. So we need a ball width or ball radius. And we're going to make that as a 12, maybe. I don't know what other values I think I should use. So the ball width kind of goes in here. We also need position of the ball. And we also need, oh, no, that's the wrong place.
Easier just to keep everything in ints rather than mixing floats and ints?
Well, I would have to cast them if that's the case. So, because it needs to be a float 32 at some point. So, okay, so yeah, I'm getting distracted here. So we have possible ball, and we want to put the ball in the middle. Okay, so vector, and then new, and then we want to do the screen width divided by 2, and the screen height divided by 2. Fortunately for us, the ball takes the middle position as its center instead of the rectangles, which takes its upper left-hand side. As you know, the graphics window is 0, 0 up top left, and 1280, 720 on the bottom right. So we need a self, and then we want position ball. Okay, right, save that first, and then run this. Okay, we're good for build. Cool, all right, so behind the chat, okay, we've got 2 paddles and we've got a ball. Okay, great. So that's good. I think okay, what do I need to do next?
You need a vector for the velocity of the ball.
You are totally right. I am going to change the color of these paddles to white. If you come up with better colors, let me know. So I also need a so that's going to be a vector, and so the starting vector is going to be a random position. So we can just get this up running first. So let's do random ball equals vector new, and then we can do it from angle, can't we? So we can do it vector from angle. Come on now. And then it takes in 360 degrees as the angle. So let's put it to 45, make sure it's working. That's incorrect. Okay, so now we need to add our, just copy this. So I know for a fact that there is an update function that you can, a trait that you can kind of hook onto. Okay, now we need to get that ball moving around. Okay, let's come back to that whilst I kind of do the player window stuff. So we can do the keyboard input event. So if we do window dot is key down, can you do that? Keyboard. Okay. I know you exist. Key S, yeah. And then can we do is down? Okay, if that's the case, then what we want to do is we want to do self position dot Y. Oh no. Okay, pedal speed. So we can move it by the pedal speed, and then pedal speed is going to equals, I don't know, 2. So if we press the S key now, it should build, but it's not liking stuff. Okay, because we need OK because it's returning the results. So you wouldn't have any of this nonsense with C++. Okay, so I think I need to include key up here. I can't remember which key it is. Quick look at the cheat sheet here. Yeah, it's just input key, isn't it? There it is. Right. Okay, cool. Save, run, see if that kind of works. Can I move the paddle? Okay, we don't have a build error, which is great. The question is, can we get a paddle moving? Okay, great. We are going the wrong way. But we have got some movement. Okay, great.
Impressive.
Okay, so
A
let's
15-minute warning, Chris.
Oh, don't tell me that. So S is, oh wait, I've done the right, no, yes, up here, this is what I want. I don't want S, I want W, because was for life or whatever. Right, so now we need the ball move. Good grief, see if I can remember how to do this. So if I do the self-position ball, and then if I get the X, then I can just plus equals the self vel ball dot X, and then I want to times it by the ball speed, which I haven't written, I think. Good grief. I could put in any value. I don't have to do all this nonsense, do I? Okay, the ball speed's going to be, that's going to be too slow, isn't it? Maybe 6. Maybe that's a good number. Yeah. Copy, paste. Does that look correct to you, Richard?
Yep.
Cool. Okay, so now if we just quickly build this, I'm wasting time building. I need to make sure it's correct before moving on, before I dig myself a bigger pit. Cool. All right, so that's probably maybe moving way too fast, actually. So, okay, so now we need to put some collisions in. Okay, so this is going to be really easy. If I can, okay, so if the, there's going to be a lot of if statements going on. So if the position ball, pos ball, dot y is greater than the screen, plus the ball radius is greater than the screen height, then that should fire. And if the position ball dot y is less, plus the ball radius is less than 0, what we want to do is you want to reverse the velocity. So you do it. So if you do self velocity vel ball,
So you probably want a minus on that second bit of arithmetic.
I think that should just do that. Okay, right, save, run. Oh, I think I've got a build error. Okay, mark me down. What have we done? Okay, I've missed a self from that. Okay, let's try that again. Oh, that's another one. That was the first one as well. Thank you. Have I got them all now? No, because this needs to be as an F32, of course. Does this like this? Yeah, okay, all right. Let me run that again. Cool. Oh, mark me down again. These damn strict types, I tell you.
Huh.
Okay, and now what we should do, we should get a ball bouncing at the bottom. That has not worked. That is not what I expected.
It's the and there, you need to make it an or.
Oh, thanks, Paul.
No problem.
A minus ball radius.
Oh, yeah, you're right as well. We should see some changes down here, though. That is not what I expected either. What we need to do is need to do the Y position, don't we? Cool, right, that should be good to go.
Mm-hmm. Just duplicate it for the X.
Well, actually, what we're going to do is we want different mechanic going the other way. I realized I'm massively running out of time. I don't have a game. I don't have any scoring. I don't have anything yet. So, so let me put some AI in it very, very quickly. So if the position ball, self-position ball, of course, possible. So if the X is, because we want to be ridiculous, so if the X is greater than the screen width divided by 2, then we want to take action. So if the ball is above the paddle, so if the position of the ball Y is greater than the position pos. Oh, I have to do self position player 2 dot y plus the paddle height. Oh, there has to be an if statement, of course. How else is going to know what to do? Then what we want to do is we want to move the paddle. If it's greater, then I think we need to move the paddle up, don't we? Yes, I think so. So I really want to check that very quickly. Have I got the logic right around here? So paddle height.
Bigger than it, then you want to reduce that.
So this is less than that.
Doesn't need to be paddle height over 2.
I think Chris said it measures the coordinates from the corner for the rectangle.
Correct, yeah, top left.
So you want it to try and center into the paddle, wouldn't you?
Cannot divide either way. Oh, just make everything float 32 then. Just get it done.
Find and replace.
Okay, cool. All right, so this hopefully should get some AI in very, very quickly. Come on now. Okay, so yeah, the paddle is moving around. Cool. All right, so we've got some pretty basic stuff going on there. So we actually need some, it needs to bounce off the paddles as well, which I'm going to have to program. But I need to reset the ball if it goes over certain widths. I've got too much stuff to do, I think. So if I position ball dot the x plus the ball radius is greater than the screen width. Maybe we can put it as an and as well. And self position dot or sorry, yeah, well done me, I suppose. Position ball dot x minus ball radius, I think, is less than 0. Then what we want to do is we want to put the ball back in the middle, and I'm just going to copy and paste this. That's not what I want. This. So position ball vector equals vector screen width divided by 2 screen width as float 32, of course. And then I'm going to quickly build this. Okay, it's building, and okay, so the ball should go through, and we got it resetting. Okay, cool. Right now we got to get bouncing off the paddle. How much time do I have left, Ciara?
7 minutes, 55 seconds.
Oh no, I've got enough time to write all this. Okay, so if position ball dot x is less than the position self dot pos play 2 dot x. So if it's greater than that, and also it's below the y positions. So y is less than it's greater than self dot position ball 2 dot y and position ball is less than position y plus paddle height as float 32, of course. Okay, can you format that down? Enter. No. Okay. Then what we would do is reverse. Here we go. Does that look good to you? Maybe not. Let's have a look.
Yeah, you want to reverse the x as well as the y.
Did I not do that?
Yeah, you want to reverse the x and not the y.
Yeah, okay. That's a good point, actually. Thank you. That's exactly what I wanted. So, oh, yeah, because I've broken it because I made the AI way too slow tonight. I can make the paddles bigger. That's what we'll do. We'll make the paddles bigger. Paddle height, 100. Okay, let's quickly do this. What I'm doing for time, Ciara, how am I doing? It has to be 1 minute, 30
5 minutes, 50 seconds left.
5 minutes, do you say?
Yeah.
I thought you said I had 1 minute.
No, 7. Did I say 1?
Oh, I misheard you.
Okay.
I misheard you. Okay. Okay, we're just going to make this a
You're
little
doing
bit.
great.
Thanks. Okay, whatever. So we're going to make this to 10 degrees. So I can just test this to make sure this paddle is actually working. So you see here, there's a lot of building between, making sure everything kind of works correctly. Yeah, that kind of works. It is a bit of clipping going on because I'm not calculating the ball radius, I don't think. That is correct. I'm not taking the ball radius. In fact, I'm not taking the ball radius everywhere. Okay, so yeah, plus ball radius. Does that look good to you? Maybe.
Too many pluses.
That's a good shout. Okay, so I said that's paddle 2. So now we want to do paddle 1. So hopefully we can just change this all to 1, and it will not work because it needs to be less than position player X plus the paddle width, because we're looking at the left-hand side instead of the right-hand side. That should be cool. So now I should be able to play a game of Pong with the AI. A couple of things that we don't have is a random start position, and we don't have scoring as well. That didn't, oh, what's going on here? Have I not, okay, you know what? Have I not done this correctly? So the pause, is that has to be minus maybe? So if it's greater than ball position plus, minus, yes, no?
So you want it to behave when it's bouncing across it because it's a circle. So it really only bounces in the middle. But
Oh no, I might have to, I think I got this wrong way around. I need to save it. Build. Am I getting bogged down in this too much? Okay, great, that works. Okay, and we've got movement here on the left-hand side. So hopefully, if I hit this ball now, okay.
Well, hey.
Yeah, it's not. Yeah, it works. It works, and that's all that matters. It's probably because that needs to be minus ball radius for some reason. Okay. So we've got the paddles in to random. Okay, I don't really want to do random. We need to get the scoring in as well, which I don't think I'm going to have time for. So let's just do random. Let's get some random in. Do I have that on the other page? Oh, yes. Okay, all right. So let me bring that in as a dependency very quickly. Get this out of the way. Rand, I want the latest rand. I don't care. Okay, so bring this in. No, so rand as an example here that I can just use. So I can just create a thread. I have to find out. I have to find out where I am. Okay, so I'm here. So okay, I'm going to really hack this together. So we're going to use this, and then we're just going to create a range between 1 and 360. Random, generate range between 1 and 360, and then that should give us a random starting position, starting angle. That's not liking that. Oh no, no. Okay, let me store that off as something. Can you tell me when I have 5 minutes left, please, Ciara?
oh, you're past 5 minutes left. Sorry, you've got 1 minute 50 seconds.
Okay, well, hopefully maybe I can just get this and we'll just have to drop the feature for the scoring, which will be quite tragic. Oh dear. Use generation. Oh, do I need to include it? Do I need to? I think I do. I think this is what it's looking for. Okay, I'm just going to build it. Okay, whilst that's building, I'm going to bring that down here for the reset. Okay, that's cool. I don't care about that. So where's it resetting? See, I'm lost now in the code. Where's the ball reset? Is this it here? Yeah, this is it. So what we want to do is we also want to randomize the initial velocity. Oh, sorry, the angle. Yes. Angle self dot fell ball equals angle. Okay, all right, cool. Let's try that. Okay, so the paddle's going up. Okay, cool. It bounces off that paddle. We got it going off the top, kind of. I think I got that wrong. I'm not sure. And then bounces off that paddle. Okay, so now the AI should lose this, and it should start in a different location and going a different way. Cool, great. So that's great. We've got the mechanics down. The only thing that we don't have is getting the score in. How much time do we have left, Ciara?
20 seconds, but
Oh yeah, that's not gonna happen. So. Cool. All right then. That's being Pong in 30 minutes, I suppose. I will take questions now, and I'll look at the scoring, and then in part 2, I'll tell you what the score is, or maybe I'll have a look at the scoring in a minute, and between one of the other talks this evening, I will tell you what the score was for Pong if you're dying to know. But the algorithm that we got for the scoring might be out, so that needs some work. Anyway, any kind of questions or any observations? Anybody? Was that fun? Was that not? Did you learn anything?
I was tempted to ask how much coffee you'd had beforehand, but I know you don't drink much. Well done.
Cool. Any kind of questions about Rust in that scenario? Any questions about the library I was using, or anything like that?
No,
Okay.
awesome.
The question was about those float numbers, why to use floats instead of integers. So if from the beginning we could maybe use integers, then we wouldn't have to cast so much.
You're totally right, because down here where it's using the creating the rectangles, they require integer values, and probably my naivety, I was like, okay, well, let's make it integer. But if you're right, if we casted it to a U32 here, and therefore we wouldn't have to cast it all the way up here. So you are probably correct. Cool. Right. Okay. Well,
and one
thank you
quick
very.
question.
Okay.
You're using the vector from Quicksilver there, right? Is there a reason you prefer using that to the one built into Rust?
So this vector isn't a list. It's just a
Oh, it's just a position vector.
Yes, it's just 2 floats, 32s, and it's got some nifty stuff in it, like from angle, and it's got some multiplication traits that I can use as well, I think. But as you can see here, I didn't use much
It's
of
a
it.
real vector rather than a
Yeah, not a
fake
collection.
computer science vector.
Yeah.
But that's 2D vector, isn't it?
True.
Cool. All right. Well, thank you very much. I suppose it's on to the next person.
Indeed. Right.
Well done, Chris.
So, Richard, it's over to you, I think.
Okay. Just share my screen. I don't know if I can compete with quite the high adrenaline of Chris's talk.
Does anyone know how original Pong worked? Was it hardware based or was it written in something?
That's a good question. I was thinking that watching Chris's talk, because I can remember having a Binatone games console which had 4 games which were a variation of Pong, and I'm sure it cost of the order of £100, which 40 years ago was quite a lot. And now, having seen it being replicated with 100 lines of code, wondering how much, quite how that worked. But I guess it was all done very low level back in those days, rather than a higher level language. But yeah, it'd be almost worth looking up to see how they were originally written. Anyway, now I'm quite interested in Chris's project rather than mine now. Okay, last Thursday, a lot of you might have seen that Microsoft announced they were going to put on a virtual conference. I'm not sure if it was actually replacing a previous or a planned physical conference. I don't think it was. I know there are a number of other conferences supposed to be going on in March and April. For instance, Bristol had the ACCU conference, which I was down to go for, but that all got cancelled in the weeks ahead, and others as well. But anyway, I saw this offering from Microsoft, and it looked like it had a reasonably interesting lineup of talks. So I thought, right, I shall try and dedicate some time to getting out of my normal workspace and actually sort of pick up some different ideas and information. But I know it's very easy to put it off and never get around to watching them. So I offered to Chris to actually give some sort of a summary of the talks, partly because it might be of interest to other people, but mostly to force me to actually get around to watching them and to thinking actively about it, about how I would explain what I'd seen there. So I'm not quite sure how this will come, because obviously each of these presenters worked hard to fine-tune their talks down to an hour or 40 minutes, and I'm going to try and summarize all 8 of them in the next 20 minutes. But then I thought my last talk was going to be 20 minutes, and I think I overran. But I'll do my best. Obviously, for the definitive version of any of the talks, go to the actual YouTube videos, most of which are up online individually. I'm not going to try and cover everything that the speakers covered, but the things that stood out to me. So it'll probably betray some of my biases. If you take it more as an abstract, so if what I say sounds interesting, then please go and follow up by looking at the talk yourselves. I'm not quite sure how to do questions and answers best. I obviously can't answer in depth about the different talks. I'm happy to, if anyone's got any particular questions about the way I've explained things, or about the process I went through watching this conference all in one day. So starting off, dynamic polymorphism with metaclasses and code injection from Cy Brand. He was also the MC, or they were also the MC for the entire conference, and did a sterling job. He and with his cats. But he started off by talking about polymorphism. So traditional C++ polymorphism. You've got a base class, animal, and 2 child classes, cat and dog, that you need to override. Works fine, but has various downsides. In particular, if you want the polymorphism, you pretty much have to allocate things on the heap and just use pointers. As soon as you've got pointers, you've then got questions about whether the pointer can be null or not. You're also losing value semantics. And if you're trying to pass a container, say a vector of your animals into algorithms, then they're not going to work. Either you've got a vector of your structure, like the animals by value vector I've got there, which would slice off all the non-base class part of each class, or you'd have to have a vector of unique pointers that would preserve the polymorphism, but now your algorithms are more complicated. You're having to put lambdas in that'll dereference through the pointers. So what Cy was looking for was a way to get polymorphism that's dynamic at runtime, so you don't know what the individual objects are going to be, but without using the virtual mechanism. So he started off by explaining a simple vtable mechanism where you would, if you like, this actually sort of reminded me of, we used to have an interview question about how to simulate C++ or implement C++ polymorphism in C. And this is basically what it is. It's have a collection of function pointers that you're going to dereference from the structure elements. So in this case, so I outlined a way of creating your cat and dog classes so that they're not tied to the animal class. They've got their own methods, and by adding enough boilerplate into animal, you'd be able to set up a vtable that would dereference from whichever object you were currently looking at and call the correct method via several calls. So you could actually, if you look at the main, you can get the effect that I wanted to get, where you could, rather than doing it by pointers, you were actually using the objects themselves. But to get it working, it did require quite a lot of boilerplate. So what the talk was about was how this might get easier in the future. In particular, you don't want to, if you've done it for animal, you don't want to have to do it for the next group of classes that you want. It was already starting to make me think of traits in Rust, and that was the direction he was heading in. Started off by describing the reflection that was coming in C++. So you'd be able to try and reduce your boilerplate by writing code that could work over the the actual structures that you're interested in, and it would generate some of the boilerplate for you. Reflection itself goes a fair way towards it. Once you've got the meta classes, you can start to interrogate the members. For instance, in this example, he was just showing how to use reflection to stringify enum values. So everything's constant, but that doesn't give you quite enough for building what was required for the type erasure that was needed. So moving further on, code injection takes it a level further. So you're still using reflection to work over the data structures you're interested in, but now you've got this extra arrow operator and the fact you've got the whole block in a const eval. So this then starts to create pieces of code at compile time in the middle of your class. So in this example, it was creating the getter automatically based on a loop over the data members you've got in your class. So this will loop over the X and the Y, and for each of them, it would pull out the type of the member and create a getX method that returns. So the return part was this type name. So it will return an int that it extracts from the type in the initial values. He would create a name by merging together the get underscore string and the member name, and then the actual code that would be injected inside the new method, in this case, was just to return the value. So it was very interesting to see an example of how reflection would be extended to allow code injection. To apply it to the example that it started with the animal, then there was an example shown of, which I haven't put all the details here, of how you would build a more generic mechanism, in this case called facade. So rather than trying to rebuild the whole mechanism from scratch each time you had a different set of concepts that you wanted to erase, you'd create one facade, and then your animal facade was just one example. So that once you've described the methods you were interested in, you could invoke all the code injection mechanism that you've created generically to turn that into something that you could then use as a sort of shareable trait. And there was suggestions that once you've got that sort of indirection, you could then specialize it for things like memory management, so that you wouldn't have to do everything via pointers. You could use small object optimizations, or you could make the function tables be held more locally rather than to try and cut down on indirection if you knew more about the individual usage. Finally, the talk finished by showing hopefully how to simplify that yet further once we get the ability to to parameterize, if you like, the actual creation of classes. So that basically reduced the amount of boilerplate that was being used in the creation of the type class for struct, I believe, to streamline it right down to the class by focusing just on the class you were interested in. But I don't think there were details exactly on how to do it. There were concerns raised that at the moment the experimental versions hadn't focused on runtime or compile time. Understandably, it could take quite a while at compile time. It also isn't widely available yet. I think possibly the biggest ideological concerns with this whole approach to effectively using traits rather than inheritance were that it doesn't work in quite the same way as concepts. Everything described here was more to do with, it's very much sort of duck typing. If the classes have got the functionality that your superclass has, then you can use it, and if they don't, you can't. So it was more about structure, whereas concepts is much more about the intent. But it was very interesting to see these sort of how these different mechanisms built on top of each other and what we might be able to do in the future, as we're trying to sort of move away from the extreme coupling of inheritance and towards something more like traits. So, completely changing direction. Nick Olnahuth then wants to very timely talk about using C++ and doing C++ development working from home. Admittedly, they're all from Microsoft, so a fair bit of it did concentrate on Microsoft's technology. So I might go through some of the feature lists a bit more rapidly than they did. There were a few things that stood out. I was aware that within Visual Studio, you can already you already have IncrediBuild to speed up your builds. So the concerns that were being raised here were that when you're working from home, you haven't got your office powerful machine. You might be stuck on a laptop with less power. So the idea was by using things like IncrediBuild, you could speed up your build processes. Probably one of the things that stood out for me more was the discussion of Visual Studio Online, which I hadn't come across before. So it looks like Microsoft are providing an entire online hosted experience for development. So you potentially can have much thinner clients yourself. You're using the online environment to connect to your repos and to do all the building and running, and you're just using your local laptop or machine as a thin client onto it, either for yourself or to share it with a team or with other colleagues. There was mention of how you pay for it. It sounded like if you've got Visual Studio, then you probably have a number of Azure credits anyway, and a certain amount of them could be used to try out their Visual Studio Online environment, but they didn't go into details on it. You could, as well as using your own client, there's also a browser-based client for Visual Studio Online, which looked basically like a browser version of Visual Studio Code, which I believe I have a slightly blurry image of that they were demonstrating. So yeah, it looked almost exactly like Visual Studio Code, but they didn't emphasize it being the same. On the collaboration side for working from home, they were pains to emphasize the live share functionality in Visual Studio, which we have tried recently as part of working from home. I've worked with Chris using live share, and it did work. It wasn't entirely intuitive, my experience, and often we wanted to refer to things that were outside of the code and environment, which obviously we couldn't. And it was a bit tricky getting the two sides of the code to follow the way we expected to. One of us would drag it and the other one wouldn't necessarily see it. But in live share, it does look like there are more features. There's a clearer follow button, so you can indicate if you're trying to follow the other person or not. And it certainly has a lot of scope for pair programming and interviews. You don't both need to have Visual Studio. One of you could be working from a browser and just follow the link and doesn't need to have anything else set up, which was news to me. There's also apparently an insiders setting within Visual Studio, which if you've enabled allows you earlier access to new features. This seems to be different from just pulling down sort of early release versions of Visual Studio. So I guess they're slightly more solid implementations of features that have been made available in existing mainline releases. Finally, they talked about, that's just an image showing on the left Visual Studio and on the right somebody live sharing from a browser. And finally, they mentioned for communication, they emphasize that Teams is wonderful, which I wouldn't wholeheartedly agree with, but it does seem to mostly work. But crucially, it is currently available free, which is good, and I'm glad to see it is, that Microsoft are trying to help out a bit. There is also a Microsoft Build conference, which I believe will also be online later this month if people are interested in build-specific areas of Microsoft. Which led us on to Erica Sweet telling us all about C++ cross-platform development with Visual Studio, and in particular WSL, which I was quite interested in because we do cross-platform building in my work. So I was interested in the Linux part. Unfortunately, she didn't discuss much about the Windows subsystem for Linux. It was mostly just about how Visual Studio allows you to connect onto that. In particular, previously, Visual Studio 2017 has only allowed you to connect to a remote system over SSH, which meant you had to have both sets of code, or two sets of the code, one on the Linux system, one on your local Windows system. Whereas now, Visual Studio 2019 gives you native support and allows you to run the Linux environment on Windows, and both of them will be running for the same set of code, which makes your source code management much more straightforward. You have to, by the sound of it, it only works at the moment with the code on the Windows side. You can't have the code on the Linux environment and then share that to the Windows build environment. I guess that's an area they're working on. CMake was emphasized a lot as being very popular for cross-platform development, and that this had been, the support for this had been enhanced a lot in Visual Studio. Visual Studio's IntelliSense covered CMake and would try and give you a lot of guidance on any warnings and errors. You weren't limited to just the Microsoft compiler, you could use Clang as well. You also don't have to use CMake, you could work with MS Build projects. I guess wasn't clear whether you could somehow it would use MS Build projects for building non-Windows builds if you were trying to build the cross-platform Linux build. Not quite sure how you necessarily do that with an MS project unless it generates a virtual CMake project or something. There was quite good integration demonstrated debugging within the Linux environment from Visual Studio. You were working directly with GDB, or not quite directly, you were working with the MI engine interface onto GDB, but so you could use all of your Visual Studio debugging buttons and tools that you're used to, but it would invoke GDB to actually do the work on Linux, or you could drop down into a console where you could use raw GDB commands as well. There was some additional warnings and help it would give you if it noticed you were doing things in the code that would work on one of your configurations but not the others. So you'd get squiggles if you were trying to, for instance, use Windows specific stuff on code that you also had a Linux configuration for. So it was looking like a fairly effective tool for trying to do cross-platform development and to give you quite a lot of support with it without having to kick off multiple separate builds. There were several talks during the day that all mentioned the VC package tool, which I hadn't come across before, but Microsoft seemed to be pushing a lot as an answer to the industry's call for a C++ package manager. So they're pushing VC package, and it's got some integration, certainly in Visual Studio, to the extent that it'll start offering you tips, presumably like when you when you use C# and you try to use functionality that you haven't imported yet, it'll offer you a little tool tip saying, do you want to import this? And it seemed to be something similar happening in Visual Studio, that it would be prompting you whether you wanted VC package to pull down something that you were trying to use. There's a little bit more on VC package in one of the later talks. That took us on a completely different direction, but something a bit closer to what I'm used to working with, text encoding. The name eventually became apparent, but this was Jean-Hide Manid, who gave an explanation about why current attempts at tackling language I guess alphabet and text encoding aren't really solved. Characters don't give you enough information. You don't really know what the characters are referring to. Is it part of a UTF encoding? Are they just standalone ASCII characters? Other character types don't really help. They've all got different, they don't really solve that problem, and they give you additional areas that you're uncertain on. WCHARs, you don't even know how big they are on different platforms. The new char 16 and char 32 were certainly problematic. When they were first released, they weren't even well defined unless certain other macros were defined. That apparently has been fixed in C++20, so char 16 and char 32 now always do have the size expected, but that still doesn't solve the problem that different applications might be using them in different ways. There are various proposals for trying to standardize the text types, but the presenter didn't really see any of them as solving it, because there's basically just too much software out there and too many people that could be using these types in different ways. Even if you went with the gut reaction that a lot of people give on this topic of just do everything in UTF-8. You've still got problems because some people will be using signed or unsigned chars and having problems, and you've still got encoding issues as to whether it's big or little endian. And it's just unrealistic to try and enforce it because there's too many other systems that you're going to be connecting to that won't do it the same way you want to do it. So he didn't seem to see any of these sort of type ideas as being a solution. What he did see as a solution was avoiding the type problem altogether and just providing a set of, or describing the standard, providing a set of tools to work with what you've got. So the idea is that for a given encoding that you understand how the characters are going to be stored in data structures or in data, you describe a single object for your encoding. So that single object, which would be a sort of static repository of how the encoding works. It reminded me a bit of how locales work. You've got a locale that describes a bunch of aspects or traits of a particular locale. This is the same idea for a particular text encoding. So the lucky 7, it transpires, refer to 3 type definitions, 2 static member variables and 2 functions. So the 3 type definitions were talking about how the data is going to be stored on disk, how the character that you translate it to and want to use it as is stored in memory. If you like I can't remember which way around was it. Code point should be the one in memory. Code unit should be on the on disk. State, if I remember rightly, was the error code as to whether you translated correctly. Then there were 2 member variables just so that users of this object would know how much data they were going to have to deal with at a time, so they could create sensible buffers. And then the 2 functions that actually do the work, encoding and decoding between effectively the data storage and the memory storage. So the idea was that there's a standard proposal for this particular object and methods, and once you've got that, the standard can then provide a number of methods for actually working with your data in a sensible, uniform way. And these 7 data items, or seven items, are sufficient to do a lot of useful operations. The only thing they didn't enable was being able to step backwards. You can step forward through text, which is the primary use case, but there isn't quite enough within those to step backwards. So that was one of the main limitations. So in C++23, they're actually going to include a number of these encoding objects for the most popular encodings. You can immediately start adding your own additional ones if you're working with other encodings, particularly if you're working with Chinese or Japanese encodings are the most popular other ones. Within a later time frame, the standard expects to include an entire suite of encodings. I hadn't come across the WG suite before, but it seems to be a catalog of a lot of used or widely used encodings that they're going to make them available in the standard. The talk then went on to demonstrate how you would use these structures to do the most obvious operations you might. So the basic operations give you enough to read the data, but a slightly more sophisticated version would be where you want to read the data in one format but write it back out in a different data format. So using the encoding objects for both the from format and the to format, they are highly composable, so you could very easily write a transcoding routine that would take you from one into your memory form and then back out to the other data form, so long as you had a common code point in between. Similarly, it was very straightforward to write a validation routine that would just go through the code, making sure that it could be translated. You could even implement the validation in terms of transcoding just by encoding or going from data format A into memory and then back out to the same data format. This was more a demonstration, I think, that how composable the ideas were rather than being a sensible way to implement it. Equally, methods like counting. It sounded like the standard proposal would actually include a lot of these basic methods. So if you provide the encoding objects describing your data, then a lot of the algorithms would already be there for you to work with. All of them were const expert as well, which was great. So it meant that when you were working in your code, for your platform, you could refer to particular coding or encodings at compile time, and the compiler would be able to statically assert that you've actually got the functionality available to work with them. I'm not sure that's the most that's the main use case, because as far as I could see, the biggest use case would be whether you can run sensibly on your clients' machines. But I guess if you're using statically linked in libraries, then you just need to check on it where you're building it. If you implement just the 7 items, then all of these algorithms will work. But I believe, by the sound of it, there are additional features. If you implemented them, then you could get some optimizations and additional functionality, like being able to step backwards through text would be possible. What else do we get? C++ development with Visual Studio Code. I've seen quite a bit of Visual Studio Code, so I probably didn't get so many things from it. I was looking out for anything that stood out. Julie Reed was demonstrating very effectively going from scratch, building a project and doing everything within Visual Studio Code. It's the one thing I noticed I hadn't noticed before is that when you're working with a C++, it does actually have a status bar that effectively has the buttons on it that you might be used to from Visual Studio or another environment. So you don't have to use the Control-Shift-P palette. You can't quite see, unfortunately, on my screenshot, but down the bottom, hidden under the toolbar, there are a bunch of status bar, and you can click on most of them, which I'd never noticed before. So I learned that much from the talk. Other than that, it's Visual Studio Code seemed to work. I use it mostly as a lightweight editor, but I know other people, Chris included, use it as a full IDE, and it certainly supports debug panes, breakpoints, everything you want with it. You can also use live share with it, as we mentioned earlier. It's available for Windows, Linux, and Mac. It does appear to be that their browser experience looks very similar, but I'm not sure whether they consider it being the same or whether they can interoperate. There was a bit more information in this talk about the VC package management tool. It sounds like the repository at the moment has 1,300 libraries in, which are all tested continuously to make sure the latest versions all build against each other, or at least that it's clear which ones are compatible with each other. What wasn't very clear was how easy it is to add new ones to it, or how much of a curated collection it is that Microsoft manages. Apparently soon you'll be able to have additional projects of your own, at least locally, so that the package manager could work against your repository as well as a central one. But there wasn't a great deal of information given, so I was just picking up clues by reading between the lines. There was some support within Visual Studio Code for working with Package Manager, in particular doing some of the configuration work. We completely changed direction and dropped back down into detailed C++, looking at concepts, which was good. I'm not 100% clear in my head about concepts and constraints, and I regularly get the two mixed up, so I was quite pleased to see this talk. The short version of a concept is that it's a predicate or a Boolean function that you can use to interrogate a type or a compile time value. And the idea of roughly, you can do just about everything already in C++ using Sphinx, and concept will just make this will make this nicer and clearer what you're doing, rather than having to effectively rely on compiler tricks. So a very simple example that Gabriel started off with was just a length function, which in this case you can see within the template, rather than the usual bland type name or class, a specific constraint has been given. In this case, the constraint that the type can be anything, but it has to satisfy the unsigned integral trait, for want of a better word. And if you try and compile anything that doesn't have, that doesn't satisfy that constraint, then it'll fail to compile. So that was a sort of a nice illustration of how smoothly concepts might actually fit into our workflow. The talk went on to discuss how you create concepts. So you need to create a function that you can use to interrogate your type, a const expr function that can work at compile time. So the example that Gabriel was working with was a slightly more realistic example than usual. It wasn't a tiny toy one. So he had a compile time table of key value pairs, looking from I can't remember if it was a string or an enum mapped onto a function pointer. So he wanted to, in fact, yes, it was from enums. That was the whole point. So he had enums as keys and then function pointers. And his point was, if the enums were all in order and didn't have any gaps, 0, 1, 2, 3, 4, then you could, rather than having to search through the enums for your value, you could just jump directly to it. So you'd have an order 1 lookup rather than an order n lookup. So what he wanted was to build a function that would examine his compile time table to check there were no gaps in the table. So it was interesting to see that. How he did that. But that's nothing new. That you were able to do that at C++14, build a const expr function that would look through your runtime table or your compile time table and check there were no missing values. So he constructed that. But what you could only do at C++14 was then do a static assert. So you could construct your table in the code and then immediately after it do a static assert that had the property you wanted, that all the values were consistent. Whereas what you really wanted was to have that constraint on the functions that use the type rather than near the instance itself. And that was where moving to concepts would be able to help you. So that to create a concept, you have the new concept keyword that would basically create your concept by linking it to the const expr function that you could already create. And then when you were creating your function that was going to make use of, in this case, their table, you'd be able to use the requires keyword so that you'd be able to specify that your function is templatized on the table that was going to be used and requires that those tables have this function. So it put together a group of these ideas and how you would make it work for your concepts. What I didn't quite get was why the requires syntax for the example he demonstrated was so different necessarily to what he'd started off with for the unsigned integral, why there were two different ways of being able to of specifying the constraint for the type, or whether they could be both done the same way, just one was easier than the other. So there are a number of questions that sort of were raised by the talk. It wasn't clear how, for instance, you might have different overloads that obeyed different constraints, or whether you could have a backup one that didn't have any constraints, whether you'd be able to sort of overload them to have sort of simple general purpose runtime ones that ran slower. But it was good to see use of constraints. And I think, yep, then they jumped onto another big new feature of C++, which I was quite happy to have re-explained to me. Let's see how much I can still remember of it. So modules. So instead of the traditional hash include mechanism for C++, modules is closer to what a lot of other languages support, where the individual modules you're imported are more standalone units that can be built separately, rather than being the C++ or C model of literally pulling the source in and having a really big source file that you then compile. So there were three key ideas for modules. The primary module interfaces, the module partitions, and the header units. So the primary module, which gets most of the key ideas, is that you might have your module file where you literally list all the things that you want to export from it. In this case, the overall module name. So even though it seems a bit odd to use the sort of semicolon notation rather than round brackets, I would have expected the overall export module name to have had an open curly bracket, closed curly bracket, but I guess they want to be able to split it across files. So instead, they introduce the module with a export module, and then all the, in this case, structures and features they want to export, and one internal type that they don't want to export, which is a bit similar to what we would have done in the past with a private, in that it stops anyone using it that isn't supposed to. But in this case, they won't even be able to get at the symbol. When you want to use it, rather than include, you use import to pull in the module, and then you can use the exported types and symbol names, but not any of the internal ones. So in this case, you've got an inline implementation of the type, which is why they needed to have the non-exported type in the same file. The module partitions are just the, if you like, expanded version of the primary module. Rather than having everything in one module file, you can split it up across multiple files, possibly to make the structure clearer, to allow different groups to work on it. Also possibly to change the dependencies. If the functions are changing more often than the types, then having the types in a module of their own would mean that that doesn't need rebuilding so much. So in their example, they showed having the types in one module. So in this case, we now don't have the function. You had a separate module for the function, which has to include the types because it uses them. Oh, no, sorry, must import them, not include them. And then finally, your main would have to, this would be the main module, if you like. So a user might be only interested in this module, so they'd import M. It in turn would import all the subparts. But when you were building, if it has the dependencies set up correctly, then it'll only need to rebuild the module partitions that have changed since last time, rather than everything. Finally, the third type was the header units, where rather than, if you noticed in the earlier ones, we were importing just the name, so import M. You can still use something a bit closer to what we're used to with the include statement, with angle brackets and quotes. So that will allow us to take a header file. You still gain some of the power of import. Basically, it'll build this module separately. And certainly the demonstrations showed a speed up in compile times if you use this. So once you'd built the m.h module separately, building this code would be considerably faster than when you used to have to hash include it. I think it was of the order of 30% faster for the example he showed, just using this form. This form, the header unit form, is the least powerful form of modules, but it is the easiest to transition to. So if you were taking an existing code base, your easiest starting point would be to turn your current includes into header unit modules. It takes considerably more reorganization of your code to take full advantage of the overall module interfaces, but that's when you get the real speed ups in build times, and as far as I can see, they were all equally safe in terms of sort of strength of what they were hiding and making available. The demonstrations included a realistic library being built where it got 10 times faster building the main compared to what it had been when it because it was able to use the modules. There were some mentions that some parts weren't fixed, that Microsoft uses a by reference module mechanism, which allowed certain aspects to be dynamically changed at runtime. But the way it was described made it sound like that was a Microsoft decision. So I'm not sure if it was just an area that the standard allows you to choose at build time or at use time, or whether they've left something open for different manufacturers, which sounded like it would make things more complicated. There did seem to be several suggestions that the build order for the modules had to be manually maintained. There was no mechanism built in that would immediately work out the dependencies between modules. And I've certainly heard questions in the past about the tooling required for modules, that not enough working versions of modules were available for manufacturers to actually be able to build tools that could work out how to combine them. But the talk did go on to say that Microsoft's particular implementation conforms to various open specifications, which in particular would allow them to be cross-used with other languages like Python. So it sounded like the module that got built had a consistent form on disk, presumably not fully binary, but it was well enough specified that some of the languages could interoperate with it, but also that tool manufacturers would be able to rely on it to build their tools between modules. So it didn't go into details about how the modules work under the hood, and it certainly raised some questions for me about if you're building these modules independently, then quite how does that mean you're going to have to distribute the built module along with your eventual source code, or do you deliver the source code for the modules and then your users build the modules themselves, in which case they've still got access to all your source code? So it didn't go into any detail, unfortunately, on where modules were on the continuum between open source and completely binary, which would then be very platform specific. Finally, Microsoft talked about how they'd been getting on with the standard library. Visual Studio in 2019, not Visual Studio 2019, they completed and finally got completely compliant with C++ 17. I believe that the long-standing problems had been to do with macros and the preprocessor, but they finally got through them all, so it's all now available. Quite interesting. I didn't know that the entire Microsoft STL is now open sourced and available on GitHub. They did a fair bit of cleaning up of the code and the make files to enable that, or to make it useful to other people to be available. They have the last few versions of Visual Studio toolkits have included updates to the STL that non-Microsoft developers have made. And they certainly seem to be appreciating having more of the industry or more of the community involved in looking at the code and helping modify it and extend it. They've still got a way to go. It's not perfect. They want to get their bug catalog onto there, and they want to do more with CMake. But I'm aware I've been monologuing for quite a while now, so I'll push on to the actual features that are in the library. They recently got the last bit, in fact, the last bit of their C++ 17 was the from chars and to chars functionality, which gives us much faster casting between strings and numbers than we've previously been able to do. I think we've tried it in work and works on Windows, but not on all platforms, or didn't at the time. But certainly is a lot faster than trying to use the older streaming operations. It does still have some, it doesn't force you to assume everything. It does still support some configuration, bases and formatting and precision of the numbers. So it's not that they've got all the speed by clamping down completely on how it works. But it was good to see that in. The C++ 20 highlights, a couple of them were fairly straightforward helper utilities, things like contains. Rather than having to do a find and then compare against the end, you've now got some things that are basically, I think, seen as easier for newcomers to C++ to find the right function. So rather than having to use the generic ones and knowing how to compare them against iterators, you can now just use Boolean conditions for contains, starts with, ends with. There was mention of the char8 and associated types, which give you some extra expressibility, I get, and you can be clear about exactly the size, but they don't seem to have full operations. You can't stream directly with them. You'd have to cast them to and from underlying traditional char types, but they can be used with other libraries, such as the file system now takes a U8 string rather than the U8 path that had previously used. Arrays and arrays if are interesting because they spoil another of my interview questions where I normally ask people about how remove and arrays interact. So there's now an arrays method, which is interesting because there are not many algorithm methods that take entire containers. Nearly all the algorithms work with iterators deliberately, whereas now arrays and arrays if have been added to the algorithms, and they take the whole container specifically so that they can pass on the actual arrays operations to the containers themselves. Is constant evaluated is now available in C++20, which will allow us to write code that can at compile time will tell you, or will tell you whether your function is being called in a compile time context. So you can have different implementations of the function, one for compile time where you might not mind it being less efficient, but it's all going to be done at compile time, or you might have a more efficient runtime version. So it's nice to see that as an answer to some of the questions we've had for a while. Very impressively, C++ is going to imminently have the const expression versions of the algorithm and utility libraries. So an awful lot more of the lookups that we want to do on strings and collections can now be done at compile time. And two very helpful containers, spans, are finally going to be released in their C++20 implementation, and the ranges library, which has been waiting on concepts, will be entirely there with its algorithms, but it did sound like there were there's other functionality that goes with ranges that wouldn't be quite available in C++20. I thought I had one slide describing what they wouldn't have done, or at least what the last things were, because there were a few things that wouldn't be in there until later next year. But the C++20 that they do expect to have in there already, or in the next build, which I think Visual Studio 16.6 should include all of these. And that was it. So I found it very, very useful. I'm glad I took notes, because even looking over it today, I was starting to get hazy on some of it. Certainly the experience of trying to watch all the talks, I got a lot more from it by doing it actively, sort of with a view to, I'm going to have to re-explain this to other people. What value am I getting from it? You know, what am I taking away? So it greatly enhanced my experience and the sort of learning I picked up. It also forced me to look at different areas that I hadn't or wasn't aware of so much. It would have been nice if there was a bit more variety. A couple of the product talks came over as a list of features, and they overlapped somewhat. Having said that, you know, all credit to Microsoft and their presenters, who nearly all of them had prepared these presentations while working from home by the look of it, and you know, gave up their time to do so. I was somewhat surprised. There was between 400 and 800 people watching the live stream. I saw a fair bit of it, and then watched some of it on the recordings on the weekend. I thought there'd actually been a lot more. But it was pretty well attended. I wouldn't be surprised if they do further offerings in the future. But I enjoyed it and learned a bit from it, and had a few things to go and look up afterwards. Hopefully that's given you guys listening at least an idea on one of them you might want to go and follow up on, and see what they actually said, as opposed to my summary of their summary. I'm happy to answer any questions if I can.
Just to add, oh, sorry.
Go for it.
So just to add to the side talk, I think there is a working version of a Clang fork on Godbolt that you can try for compiling the stuff with meta classes and compile time reflection.
Okay.
And I think also on his talk, Herb Suter was responding to people, and he said it's very unlikely to get the C++ So the runtime compile time reflection in CPP 23, unfortunately, and especially that this COVID stuff is probably slowing down a little bit of language evolution, and Herb is trying to keep the 3 release pace pretty strict. So we might not be able to see it, unfortunately. And the compile time reflection would enable like so many new things in the language, like even that code generation. So we wouldn't have to write the boilerplate in and nothing like that. So we would just import libraries, call something, and they would do proxying and so on for you, which would be really good.
It would be great if we could, even if we could only get the sort of first part of the reflection, even if it didn't get as far as the code injection. The reflection itself would give us an enormous amount.
Definitely.
Thanks, Richard. That was pretty awesome. Do you know or have any indication that the modules will solve cyclical dependency issues?
I believe they should solve cyclical dependency problems, because anytime you try to build the module, it will have to, well, it should separate the concerns slightly. I mean, it's a bit like our forward declarations that we have at the moment. The module should, when it's being built, will only rely on the interface that is exported from the module it's trying to use, rather than the implementation. So, I mean, I guess I don't know enough of the details about it. That sort of implies that you should be able to somehow build the module so you've just got the exported interface that other modules could use, without having to build all the internals of the module, because otherwise you could end up back at the same cyclic situation. All the talks I've heard from anyone in the sort of compiler industry admittedly are a few months out of date, but I've always talked about the difficulty they've had of working out how to get the tooling working around modules. So it certainly sounded like there's quite a lot still to be nailed down. So I've been quite surprised that it is actually making it into C++ 20. But Microsoft, I mean, possibly this is where some of the points that they made about by reference, maybe there are some things that just weren't nailed down that firmly in the standard, and that they deliberately ended up just trying to leave open so that implementers could have some flexibility to try and solve some of the problems, rather than sort of mandating a solution for everyone. I believe the modules are supposed to help reduce cyclic problems, but that to me sort of implies a particular implementation, but I can't be certain. They didn't mention anything in the talk about it, unfortunately. I know in our work, the DevOps are greatly hoping that it'll improve build times, which I guess it will if it enforces more modularity, so that you can build things independently, so you can have more reliable incremental builds. But I think that'll be mostly by forcing a particular refactoring of the code, and some of that you can already get by being more disciplined with your header files.
Great, thanks.
I think it will only improve the incremental builds, right? Not the builds when you start from scratch, because then you have even more dependency. And I think the problem is that the modules have to be parsed first to create a dependency graph, and then to kick off the build. And that's what people were saying that is a disadvantage in comparison to the current state of matters. Yeah,
that's what I gathered. Was, I mean, from watching the demonstrations, the chap doing it, Cameron, did have to keep fiddling with adding things into his dependency lists manually, which I was a bit surprised at. Whereas, with reasonable care, your hash includes at least do give you a dependency tree, even if it isn't always the most efficient. It looked like at best modules would give you the same sort of speed up as you get with pre-compiled headers, in that all the code that's going to be sharing a common lump will be able to take advantage of it. It still has to be built once, and the other code will be able to use it. But at the same time, PCHs don't get distributed and are binary and are platform dependent, whereas my understanding was that modules are not supposed to be quite so platform dependent, so it must be somewhere in between. But that would imply there's still more build time.
I think at least they are vendor dependent. I don't think there is a standard that everyone is gonna follow. So if it's not mentioned, like the representation is not mentioned in the standard, then everybody can choose whatever they want.
Yeah.
But I also am not fresh with the knowledge on modules, unfortunately.
It might be suitable for a follow-up to your ABI talk, Christoph.
Yeah, I know.
when there's enough of a working example to try it out.
Exactly.
I've included the links within here if anyone wants to go back to the original Microsoft talks, which I'd sort of highly recommend. They were pretty good. The longest one, the one I've mentioned on here, is the full 8.5 hours YouTube presentation. So that does include all of the question and answer sessions as well. I believe technically the Q&A after the first few talks had problems with the sound dropping in and out. So for a lot of the later talks, they just took questions via the chat. But you can, if you want to, sit through the YouTube and watch the chat. If anyone's interested in my slides and my summary or wants to just go back and check what the YouTube links, then it's up on my GitHub, which you're welcome to access and take what you can from them.
Awesome. Thanks, Richard.
My pleasure. I've no idea how long that took. Probably longer than the 20 minutes I aimed for.
It's all good. And I think now it's over to Hugh, which is good because we've had quite a C++ heavy middle bit, and then sandwiched by Rust on either end.
Cool. Yeah, I'll start now. Right, so I think everybody should be able to.
Yep. Yeah, we can see that.
Should be a full screen on here. So, okay, so I'm going to be I'm going to be discussing kind of real life projects out there that are using Rust. But before I want to talk about those, I'd like to talk about why Rust is good. But I personally like Rust because it's really good at memory safety. You have fearless concurrency, and you also have good performance out of the builds. The memory safety stops things like buffer overflows and out of bounds access, etc. Fearless concurrency allows you to do multi-thread stuff without worrying about whether something is wrapped in a mutex or a spin lock or whatever. The borrow checker will actually kind of advise you to use to wrap mutexes or like variables for threads they're using, and overall, as the Rust compiler is using the LLVM project, it can produce fast builds. So kind of the first company I'd like to talk about is Mozilla. They obviously kind of funded the Rust project, and they overall kind of kickstarted it off. So Mozilla have a few projects. One of them is Stylo. Firefox currently uses the Stylo calculation engine for CSS calculations. Mozilla is working on WebRender, which is a new web render within the web browser. So that will be able to draw everything that's on the screen. I've also found out that some people in Mozilla are working on a new front end of SpiderMonkey, the JavaScript engine. And the first project Mozilla started is the MP4 metadata parser, and that's had quite a lot of success since it first began. If anybody wanted to look at more projects for Rust projects for Mozilla working on, you can kind of go to the link here. So I'd like to talk about another web browser named Servo. It's entirely built in Rust, and it's very good. it doesn't use anything like from the Gecko engine in Firefox, except for SpiderMonkey. It's very parallel. It's quite fast, and it's also very experimental. So I'd like to show everybody here this on my machine, but unfortunately it doesn't work. Facebook, I've even kind of I've used Rust to generate a cryptocurrency. They did kind of start to work with other companies, but the whole project fell over due to privacy concerns. But the overall project would give you a simple global payment and financing infrastructure, but it powers billions of people, but that never happened. So Dropbox have a file system named Magic Pocket. So several components of the file system is written in Rust, and over 500 people are using the system inadvertently. So next, I'd like to talk about Deno. So Deno is a secure runtime for JavaScript and TypeScript. It's written in a number of languages, but it does use Rust for a good chunk. So Google's own operating system, Fuchsia. Some parts of that operating system are written in Rust. And if anybody did want to try the operating system out, it does work, and I'm sure you can try it on your machine. If anybody would be interested in having an LS Unix command replacement, Exa would be a good option. It has things like nice color, it's fast, and shows a lot of metadata here. So yeah, and in the end, it's a single binary as well, which is pretty nice. So some parts of HVM, the previously PHP JIT compiler and previously compiler for PHP has had some parts rewritten in Rust. Currently, HVM only works with Facebook's own language hack. But yeah, it's quite interesting to see like big companies like Facebook were writing some components from OCaml to Rust. So some parts of the system that have been rewritten are the parser and the code generator. So there's an entirely Rust-based operating system named Redux OS. It's quite new. It looks quite nice. The entirety of the operating system is written in Rust, whether it be the calculator, the picture viewer, calendar, the OS itself. The OS has a really cool file system written in Rust, which is similar to ZFS. So that's quite interesting. So now I'd like to do a demo of two things that are running on Rust right now. So one of them will be Firefox itself, and this actual presentation is running on WebRender. So throughout the entire presentation, I've been using Rust in the backend. So if you go here, you can see that it's using WebRender, and the architecture of WebRender is a bit better than the the previous kind of composer, etc. So I don't have to pause and working on my machine, so it is a bit slower than usual. And so the last demo I'd like to show is Redux OS itself. So I'm going to start it up here. Let's do it in front. So here's the login screen for Redux OS. Login. You can see system. Can everybody see that, right? Yeah. Okay.
Yeah, I can see that.
So, yeah. In Redux OS we have a terminal. when it loads. Oh, we have a symbol of file manager. We have calculator, calendar, a little picture viewer, character viewer. I can't remember what this is. But yeah, we also have a web browser as well. So it uses the net surf web browser. Everything is quite slow because it is running in a Cuma VM. So you can see here we are browsing website. Yeah. So there's a bunch of other companies and projects out there using Rust. If anybody would like to kind of have a look, you can go to this URL here. So the conclusion of this is Rust is used in production. Over time, the usage of Rust is going to increase. And a lot of these companies have been using Rust for important components of their systems, so things that probably are safety critical, or I wouldn't say much safety critical, but stuff that's important to them. Probably things that make money, make critical decisions for the company, etc. So, yeah, any questions?
Thanks a lot for that, Hugh. I've got a quick question about, is it Redux? Is that how you pronounce it?
Yes, Redux, yeah.
Yeah, so is Redux life dependent entirely on its community supporting it, like building applications for it?
I'm not sure about that. But there's one person employed by System 76, and I think he's having a little bit of funding for this project. But yeah, it is mainly a community project.
So do you see it kind of catching on? Do you see it as kind of like, challenging, other distros?
I don't know. Graphical wise, it's quite slow, and I think it could. I think the person who kind of made this wants to integrate Mesa, the graphics or whatever into this system. I think Redux would be good for a web server. The 7 doesn't have graphics. So yeah.
Okay, thank you.
Did you build Redux from source? And if so, how long did it take to build?
I downloaded Redux online on the website.
Okay.
So I didn't compile it.
Yeah. I'll have to try that.
I just want to note that the web browser within the system is actually written in C. So I'll be quite curious to see how it kind of it works on the OS. Yeah.
I had a question, Hugh. Thanks for the sort of roundup of all the. It's good to see how many companies are using Rust. You mentioned a couple of projects like Servo and Redux OS that are all Rust. Does that include all the libraries they're pulling in? I mean, are they written from the ground up in Rust, or are they pulling in components for other things like the low-level graphics or the file handling that may have been written in other languages? They're just ring-fenced in sort of safe interfaces for Rust.
I think with these projects, they probably be about 95% Rust. So today I looked at Redux, for example, and 85% of it is Rust, and there's only a tiny amount of it C++, but I didn't look into what the C++ was used for. Yeah, I mean, like it's quite cool to see like Redux have its own file system built in Rust. I think that's quite interesting. Yeah, I guess the OS will probably use other Rust libraries for.
That is cool. I mean, I did hear one quote, admittedly a while back, that Mozilla's use of Rust had an awful lot of unsafe blocks. I don't know how prevalent that is in sort of real world Rust software.
It is, yeah, unfortunately.
I mean, it's good that there is a mechanism to try and contain it and make them explicit, but it's interesting to see how. I'd be interested to know if that's because you can't do what you want without an unsafe block, or if it's merely less efficient.
A bit of both, I think. So I guess for like a video coding, for example, Rave, that's another Rust project I have included in the presentation. But sometimes uses unsafe code for to kind of with assembly inside to kind of speed things up. Rust does have foreign function interfaces, which allows it to kind of interface with C applications, sorry, C code. So that's another area where developers can kind of use to integrate with existing software.
Thanks.
I guess inherently, as soon as you start interfacing with anything outside of Rust, you're going to be unsafe. There's not really
pretty
much
much,
of a way around that.
Yeah. Yeah, I mean, I think it'd be really nice if everything was written in Rust, but it's a lot of probably like millions of years of effort being put into software, and it'd be really difficult to replicate everything. But I think at least with a pretty much fully Rust operating system is a good start.
The other slide that caught my eye was you mentioned about HHVM using just-in-time compilation. Do you mean compilation of Rust on demand?
Oh no, that would be with their language hack, which is kind of a derivative of PHP.
So they've written a compiler for hack in Rust that they run on demand against a random script that a user might provide.
Yeah, I think it's only a few parts of HHVM have actually been written from OCaml to Rust. But yeah.
Hack is like a typed version of PHP, isn't it? From memory.
Yes, it is. Yeah.
Yeah, and they were looking at to basically make their servers run faster because Facebook used a lot of PHP, so it's worth them developing it just to save money. Yeah, I don't know much about it other than that.
Yeah, I mean, there's a few other Rust projects I can name top of my head. So this might be interesting for Chris. So it's graphic RS. So it's like a Vulkan-like low-level API that can interface with Vulkan, DirectX 12, Metal, OpenGL 2.1, etc. So people to like 3D stuff might want to use this.
I have been using that for a bit, and I've been following an amazing tutorial on using it as well. It's fantastic. It's so cool just to make my own kind of render across platform and not worry about the graphics API that I'm targeting.
Yeah. There's another Rust project I think of as Pathfinder. It's a GPU rasterizer built on Rust. So that's quite cool. If you need to kind of like 2D graphics and stuff.
This is a new one, isn't it?
It's pretty old. It's made by PC World and Mozilla. So yeah, I guess this might be integrated with WebRender in the future. Yeah, that's the end of my presentation anyway.
That was great. Thanks, Dean.
Thank you.
Thanks.
I really enjoyed that. I think now it's time to move over to some lightning talks. I think we've just got one lightning talk from David, unless anyone else has anything lightning they want to share. No, okay. So over to you.
Hi everyone, can you all hear me?
Yep.
Yeah.
Okay, I'll share the screen. Okay, my talk will be on exposing C++ to Unreal Engine. So a little bit about me, I've been in some game jams and I do a lot of work in Unreal Engine. Unreal Engine can be used for a lot of things, not just games, but any kind of real-time rendering, virtual production. But it uses C++, and that's a problem because it can be slow to compile, especially when you need to make a lot of changes to things in your game, like damage, car speed. You need to test this out. So you use properties. It lets you expose values to designers and extend the code without recompiling every time. Essentially, this just uses macros, which will generate some static reflection code for you. Mainly, it's the uProperty macro above all of these variables that generates that code. And then you have this menu that appears, and you can edit things, you can edit numbers, colors, and it's quite intuitive. I have a quick demo to show. So this is basically a dog class that has a name, for color, some basic variables. And this is the dog implemented, and can change its color without having to recompile. And whoops, I can also change his name and his tag. There we go. That's my lightning talk.
Thanks, David. Has anyone got any questions about that?
Can you actually tie the properties to sort of to a separate feed, like a text file or something? Could you actually, rather than just using it as part of the design experience, could you actually use it as a way to get the Unreal application and objects to respond to, say, a live feed of temperatures or something?
You can definitely use that with inputs from, I don't know, like the keyboard or something. But if you want to put in a configuration file, you can mark it as config. There's a lot of specifiers that you can use, but I believe that's only on startup that it's checked in the configuration file.
Okay.
Do you lose much in the way of performance by doing this? What do the macros actually have in them?
Macros actually have nothing in them. It's actually using its own tool called Unreal Header Tool, which generates a lot of codes in the backend in here. So this all gets statically compiled. So there's relatively little overheads.
So it's more like a pre-compiler,
Yeah,
like we used to get
yeah.
with, like we used to be able to embed SQL into code, and you'd basically just run a pre-compiler and turn it into a bunch of C calls, or much expanded bunch of C calls. Ah.
Yeah. This is actually what's generated. Basically just loads and loads of macros, and yeah.
It's beautiful.
It makes us cry. Such beautiful.
You can also extend it in a visual scripting system that they have. So you can mark your variables as like read-only, or you can make them getters and setters, and they're automatically generated. This is basically how I made the dog collar change the text when you changed it in the value.
Does the blueprint, does it generate a Unreal script, or does it generate C++ code?
This doesn't generate C++, but you can enable it if you want. It takes a bit of time to compile it into C++, but actually it's just run in its own virtual machine.
So when you bake the game, how does that information get sent across to the to the binaries? Does it still run within the virtual machine when it's executing this this graph?
Yeah, it's still running a VM, but if you want, there's actually an option in the packaging to nativize the blueprints, which just generates C++ for it. It is somewhere in here. You can enable blueprint nativization. That only works in the packaged builds.
Nice, thank you.
So you showed us you're changing colors in the text. Can you only use properties for simple properties like numbers and strings, or could you actually use it? I'm just trying to think if you could use it to inject some sort of logic if the user wanted to control how something was calculated.
Yeah, you can create like functions and stuff. You can get these variables that you've used, can do all sorts of things to them. So this is actually a really designer-friendly way to sort of have these configuration variables edited without even writing C++ codes.
Which I'm sure a lot of designers appreciate.
Yeah, but then when you call the C++ codes from within this visual scripting system, it runs at native speeds, I believe.
Nice.
And I suppose that's an advantage over Unity, would you say? Or does
Yeah,
Unity...
with Unity, it's all C#, so I'm not really sure about that. It does generate C++ when you package the game as well. So I'm sure that would have a similar effect to nativizing the blueprints. But one thing in Unity is it actually just exposes all of your public variables, whereas in Unreal Engine, you actually have a bit more control when you put these macros down. You don't have to just export everything that's public.
And what advantages does that give you?
You can basically control what a designer has access over.
Gotcha. Gotcha. Yeah, that makes sense. Thanks.
Yeah.
Awesome. Does anyone else have any questions? No? All right, in which case that's pretty much the end of the meetup, apart from chit chat at the end now. Anyone has anything in the C++ or Rust world they want to discuss? No, I think everyone's C++ and Rusted out. If anyone who said, I think most people here have been here before, but anyone who hasn't, if you are looking for somewhere to get started with Rust, obviously, if anyone mentioned the Rust book today, that's your go-to. But you can message any of us really, or just post on the Meetup page if you've got any questions afterwards about the talks.
So you're going to post the video to YouTube again, Ciara?
Yeah, that's the plan. That is the plan. It's been recorded, so makes sense.
And we're going to have a link with all the with the timestamps in the video this time.
Yes. Yeah.
Right.
Wait, did we not have that last time?
I don't know. I haven't watched it.
Oh, I was going to say, I thought I did that, but maybe I didn't. To double check. But yeah, we'll get that added. We have a YouTube channel. If anyone wants to create any content and they want it posted to the Rust and C++ YouTube channel, we now have one. So exciting times. Yeah, I think with that, does anyone have anything else, or should we call it a day?
I think we're done. Thank you, Ciara.
Yeah, thanks, Ciara. Thanks for emceeing that.
Sorry.
Thank you very much.
It's a thankless task, isn't it?
Pretty low maintenance task, so I don't mind it. And yeah, we'll probably try and do another meetup in, I would guess, a month, depending on how things go with lockdown. I imagine it will still be virtual, looking at the way things are at the minute. If anyone does want to talk, or if people would rather do a code jam or a hackathon or anything, then let us know. That's something we could potentially do instead if you fancy it. Well done, sir.
An online hackathon.
Ciara. And now that we've seen the Visual Studio's coding capabilities, we've got all these online.
Yep.
Yeah, no, I mean, we could. We genuinely could. You could set little tasks and contribute. You know, GitHub, all of us are doing code remotely now. So why not have a hackathon remotely if we want to, or a tutorial or anything?
I don't really see advantages of Visual Code Studio pairing over anything that you can share the desktop with and then give a remote control.
Yeah, exactly.
Maybe if you want to sandbox someone just to see the editor, but then you're still gonna be watching what he's doing probably.
Yeah, so probably complete code collaboration wouldn't quite work, but
Maybe when it scales to hundreds of people modding. Not sure how that would work anyway.
Okay, people are free to leave the
Yes.
meetup. You don't have to stay. You can leave.
Yeah, so thanks for coming, everyone. See you next time.
Thanks,
Thank you
guys.
guys for all the effort.
Yep.
Thank you for this.
And if anyone wants to talk,
Well, thank
next
you.
week-
It was really
Yeah.
awesome. Cheers, guys.
Stay well.
Safe coding.
I'll kill the meeting for everyone.
End it now, Ciara. End
You're
it.
too polite.
Shut it down. Shut it down.